Thank you, everyone, for joining us this late afternoon, early evening for what is our last lecture in the Design Tech lecture series for the fall semester. For those of you that don't know, I'm Jenny Sabin, both professor in architecture and also design tech, and the chair of the new multi-college department of design tech. And it's my pleasure to introduce Daniel Leithinger, who is currently one of our Design Tech Innovation Fellows, spending a full academic year with us in the department and co-teaching the required course Design for Physical Interaction. Daniel is also a visiting assistant professor at the University of Colorado Boulder, and he invents human-computer interfaces that push digital information past the boundaries of flat displays and into the real world. He received his PhD in 2015 from the MIT Media Lab with a focus on tangible computer interfaces that can programmatically change their shape and materiality. And his dissertation was advised by Hiroshi Ishii of the Tangible Media Group at the Media Lab. Together with his colleagues, he has invented a series of award-winning computer interfaces, which have been presented at venues like SIGGRAPH, Arts Electronica, and the Cooper Hewitt National Design Museum. These projects have also been widely featured in international news and have been awarded by premier entities including Fast Company, Red Dot, SIGGRAPH, and Laval Virtual, and many more. Daniel had the privilege to work in diverse research labs, including at Ars Electronica in Linz, Austria, also at the Media Interaction Lab, also in Austria, the Interactive Media Lab in Singapore, the Disney Research Lab in Pittsburgh, and also with Microsoft Research. And he co-founded the company Lumi Inc., now known as Fathom Optics, which is a glasses-free 3D display technology company. Past industry collaborations include companies like Adobe Research, Shell, Ericsson, Olympus, and many others. And this work has resulted in a new camera product in some instances, as well as an interactive backpack concept. And the work has also been featured in the Milan Design Week. So please join me in welcoming Daniel to the stage. We really look forward to your lecture.
Thank you very much, Jenny. The microphone's working well? Okay. I should mention a correction, probably from all the stuff that I sent. I have never worked at Microsoft Research, but we worked with Microsoft Research. And if somebody from Microsoft Research is watching this talk, you know, I'm here. Give me a call. I think my email address will probably be at the end of this. I had the privilege of giving a talk here in Ithaca back in 2022. I think it was called Designing Elastic Spaces. When I looked through my past presentations, I was actually wondering, has anybody here in the room seen the talk that was back then? If you have, please raise your hand. Don't be shy. I'm really glad, because there was some slides, and I was like, I wanted to include some materials that I spoke about 2 years ago, and then I was like, I shouldn't be too redundant. But so I'm gonna start with the slide that I showed 2 years ago, and I've shown a couple of times when I talk about my work, even though it's not my work, and that's this wonderful image here that I found on Flickr by Diana Robinson, just because I think everything that I do in terms of my work relates to this image. And just take it in for a moment, ignore the image credit, and think about everything that's going on here, right? There's learning, there's interpersonal relationship. Quite beautiful. Has anybody seen the British pottery show? There's always the person that cries when the pots turn out really nicely. That's how I feel about this one. And so we compared it to computing today, like the learning experience here, and that's of course the usual diminished. This was an image I pulled during COVID, where that was particularly heinous, just as a situation, and that's obviously a very diminished experience that we have. In the most wonderful book, Abstracting Craft by Malcolm McCullough, he describes this situation as, in computing, the eyes are in charge and the hands are unemployed. And for somebody who likes to think with their hands and with their body, that's not the situation that we should be confronted with in 2024, in my opinion. And then there are actually a lot of innovations. Every big technology company that has money to burn, and they have lots, especially since they keep firing their employees for no reason, is looking for what the next platform is, because everybody knows, you own iOS or you own Android. That means you take a 30% cut if you get through all the court cases. And so everybody wants to kind of define what is the future of computing for very real reasons. Here we have an example of somebody working very hard on that. And I'm not trying to be cynical about that, because I truly think that Mark Zuckerberg has a great vision of where he wants to take this, and obviously a big incentive. And I think it's nicer spending billions on a new computing platform than it is on an experience, than it is just spending things on AI and ed tech. So, but still, there is something that does not feel like this is the future that I want to live in. And maybe that resonates with some people in the room. So for me, I grew up in a weird moment in time, I would say. I didn't know it back then, nobody does. But then when you reflect back, you're like, I grew up in the 80s as a child, that dates me, and didn't have a cell phone or the internet, but still had a lot of sci-fi kind of around, right? We all watched the movies, Back to the Future and co. And then in the 90s, kind of when I was a teenager, the internet suddenly was there, and it felt like we had arrived, right? And that's a really profound moment, I think, to experience, because now I have all the same things that my daughter will have access to at some point, but I kind of grew up without them, and maybe there's digital native or whatever you want to call it. I still think that there's this ginormous unfulfilled promise that goes back even before the 80s. And I think what shaped me mostly when I think about computers is kind of this outside-in, like science fiction view, where I would go to art museums, where I would watch movies and kind of envision of what computing should be like. This is the dystopian version. One utopian version that I was very inspired by was in going back before I was born, this vision by Gianni Colombo about Spazio Elastico is the original title, about elastic spaces, like this idea that we think about an environment that can truly transform, that can help us to think and to change our minds, both figuratively and literally. And so programmable environments are something that we pretty much only see in art museums. And I was lucky enough to during my undergraduate studies in Austria, to randomly have been born close to Linz, Austria, where Ars Electronica, one of the media arts museums and festivals, is located. And so I did a summer internship as a young wee undergrad in 2004, and was really inspired by all the art that I saw there. I had gone there as a teenager, then I started working, and for me, one of the projects, and there was a lot of work similar to what Gianni Colombo had proposed. By the way, I haven't really described, this is essentially a space that is defined by all these strings that are kind of like, in a completely black room. You have all these strings that are lit up with like black lights. And when you walk into the room, your space is completely defined by these strings. You don't see anything else from the room because it's black. And then all these springs are pulled by motors that are outside the room. So your room suddenly starts to expand and contract and change. And it also, there's multiple people in the room, kind of what you see in the sketch on the right here. And you're like, what's happening? In 1967, that's pretty cool. So for me, my big aha moment was when I was in the Ars Electronica Museum, and I was working in the basement on an exhibit, really wonderful exhibit, trying to understand why the computers kept crashing, because we didn't have an idea of pointers back then and memory management. And upstairs, coincidentally, at the same time, the Tangible Media Group had an exhibit for 2 years installed in the museum. So I would go like literally in the middle of the night, and I was like sick and tired of like my computer crashing. And the exhibit, it was like eerie. You go through this museum, multiple floors, everything, but some things are turned on. And this project was always my favorite. So I've not shown any of my own work. Please forgive me for that so far. But this project has been really influential to me. It's called Sandscape, and actually I didn't write Sandscape here, but Sandscape is essentially a sandbox. And for those of you who are landscape architect, this is meant for you. The idea is that rather than using any CAD software to manipulate a model, drag around vertices, to make a 3D model and run a simulation on that, you play with sand. So you make a sand model, a physical sand model, you put objects inside, and this box will continuously scan your model, run a simulation on that, and then you can kind of see on the wall, there's a 3D representation of it, and then also the simulation is projected back onto this sandbox. And for me, what was beautiful, for one, it's kind of cool, you see where like the water will drain as you like change where a lake will emerge and so on. And as this during different times of the day, which slope gets like more sunlight and so on. So that's really cool. But for me, it was really also about the visceral experience of it. You kind of run your fingers through, and it's like tangible bits. You really feel like you're touching them, right? And so for me, that was like the moment where I was like, this is what I want to do. So literally 20 years ago now. And I want to build interfaces like this. And at some point after my undergrad and some stints here and there, I got to join the Tangible Media Group in 2008. And this was the first project I worked on, actually reviving this project because depth sensing cameras, like the technology that is necessary to kind of make this 3D model in real time, had become really cheap and accessible when Microsoft released the Kinect. And so we did like a very cheap version of the Sandscape. And now you see a lot of these various universities and research groups have done like open source versions of this to teach GIS and other versions. And I think it's one of the most beautiful examples of tangible interfaces. The only issue with that is, for one, you don't get a master's degree just by recreating what others have done before, a little better, a little faster maybe. But also, when you play with this, you actually encounter there's a lot of issues, right? Especially if you use CAD software. Back then, it was like 3ds Max and Rhino for me. And I was like, you want to modify a detail and you can't zoom in, right? Or you want to say everything should be flat, like right away, right? You want to have like some procedural operations. That's impossible. You can't like easily save and send this over and then it's recreated on your collaborators' end. So we were constantly thinking about like the issue is the sensing works really well, but the output is still only pixels. We're projecting them on the material, but it's still only like static, and that's constantly the limiting factor. So during my master's, I was like, how can we build a Sandscape that is dynamic, where I can program it, where I can do whatever I want with it. I can zoom in, I can load models, I can save them, and I can still deform by hand. So my big break came when I on eBay found these mixing board faders that I usually used in audio mixing boards. There's probably one in the back there, in the audio console. They're just a simple slide pot and then a little motor that drives it, right? And so with that, you can make yourself a nice little pin that is computationally controllable when you turn it into a servo. And I was at this lucky point of time where Arduinos suddenly became available. I was in a place where laser cutters were very available. And so that was my first project, just figuring out how to do hardware, because I'd never really done that before. I was really coming from a software background back then. And so I built more and more of these pins that could move, put them in a tabletop, and then put a stretchy spandex top on top and started like projecting on it. And was like, this is like motorized Sandscape. That was literally, here you can see a version of that. I hope all the videos are working. Let me see. There we go. So you can see this is like Google Maps, essentially. You have a satellite image that is projected on top of this table. And then you can use your gestures, because we had access to a Kinect. So you could use your gestures to move and rotate. You could always go in and like deform directly with your hands. Improvise with found objects on top. And the idea was really, this was kind of like a digital clay interface for landscapes, right? And I didn't really know what to do next after this. But one thing that was clear was that this spandex surface and these pins, in this case, they were like, I'm trying to remember, because it's a square, like 120 or 128 pins that were all computationally controlled, was just too limited, right, in how much you can do with it. So that's when I started collaborating with Sean Fulmer, who also joined as a grad student back then, and we were like, let's build higher resolution displays. This is one of them, and that was. We built and published this back in 2013. In this case, we have 900 motors, so 30 by 30 pins. They're the same mixing board faders as the display you saw before. But because now we have a fidelity that is much higher, we can actually start doing interesting things with it that weren't possible before. Like, for instance, this idea of like making a version of Zoom where you can not only like see each other's face, but you can like put your hands or any object underneath the depth sensing camera and start improvising with that. That kind of like what we call physical telepresence. And we were also playing a lot with this concept of like, if we have physical telepresence, there's always the idea, there's a very common concept in telepresence, this beyond being there. So you don't just want to replicate a place. You may also want to modify your body. You may want to like start scaling your hands. You have ginormous ones, or you may want to start multiplying them. So you have 10 hands instead of 2. This is my advice at Hiroshi. We put this in to bring. And one big insight for us was this idea that it wouldn't just be about the shape display, it would really be about how this display, because now it's in the world and it's modifying the world, interacts with our hands and with objects on top of it. There's this concept in tangible interfaces and in human-computer interaction in general called affordances. And affordances are essentially how an object affords us to use it, right? So I have a button, I can press that button. If we have a dynamic interface like this, the affordances are dynamic. So we can start to program affordances, and we can guide people in how they can use digital information with their body. So for me, this was a really wonderful project. It was like halfway through my PhD. I was immensely grateful that my advisor had like banked a lot of money of his research money to like have us buy the hardware and support us with it. And for some reason, it blew up on social media back then, like YouTube and Vimeo, and we were invited to a lot of talks and got a lot of nice press. But it's also this moment where you're like, what's next, right? And that's kind of funny because I keep getting that. Like when I look at it now, I feel like I don't know how many times I've seen this video, but I keep seeing it whether I want to or not. Like literally last week, for instance, my sister-in-law sent me this and was like, "You're on Instagram." I have no idea what he's saying. Does anybody in the room speak Hindi?
है ना शॉकिंग इस टेक्नोलॉजी
Oh,
को
a few
डेंजर
people.
यूजर इंटरफेस कहते हैं
Maybe you
जिसमें
can-
स्पेशल सेंसर्स ऑब्जेक्ट की शेप और
Special
movement को
sensors?
डिटेक्ट
I
करके
hear
वो
that.
डेटा इन
Object.
पिक्सेल्स तक ट्रांसमिट करते हैं जिसके बाद ये पिक्सेल्स उस बंदे की मूवमेंट की तरह ही मूव करते हैं कहने का मतलब ये है कि अब आप हजारों मील दूर बैठे
Something
हुए
about
भी अपने
movement.
प्यारों को छू पाओगे
I definitely, long distance relationships got a lot more interesting or something like that. I think it's this. And that's funny because that was like literally the original like Reddit post that made the original video viral. So I'm like, joke's on you. That people have been making this joke 10 years ago. But so it keeps popping up again and again and again. And it's kind of interesting. And part of me in like thinking about talks like this is also like trying to reflect of like, why do things sometimes inspire and sometimes don't? But one thing for me in terms of like what's next was like just thinking about now what, right? Like after I graduated, I was like, this is nice. I got like a few plane tickets out of it and talks and job interviews, but I still don't know what's next, right? And so part of me, was thinking, so I got a ton of inquiries constantly, and I keep getting them. It's kind of funny. Like people email and like, you know, for the shape displays, are like, can you like send one? And they were like, we don't need the whole table. Just send the top part. We just want the moving part. And there's constantly like, can you build this into a phone, for instance? You know, I'd really like this as a phone. Can you make it so it doesn't make all this noise, you know, all these things. And I'm like, yeah, all of that is actually very reasonable. I would love it to be compact and in my phone and not have a lot of noise. So a lot of my subsequent work, like after my PhD, I was kind of like, I'm going to try a startup because I'm in America and I can get venture capital money. And that was actually a ton of fun. But then at some point I was like, venture capitalists are gross and startups are no fun because you have to pivot. So I'm going to go back to academia. And so I was on the job market, and then I started at CU Boulder, and I was a professor there for 5 years, up until last year. And I was like, I'm gonna think about shape displays. I'm gonna do two big things: technology and design. I should have done it different. Design tech. I'm gonna do design tech. So I'm gonna do the technology, all the things that people have constantly been bugging me about. So it should be like better than just 2.5D. The pen shouldn't just be able to move up and down. They should be able to do more interesting things. I also wanted to be, so that's more expressive. I wanted maybe not just this redly rigid assembly, right, with electromotors. So we wanted to be compliant. We wanted to have more degrees of freedom. We wanted to, the scale should be different. So it should be tiny or ginormous, right? And then also actuation mechanisms. Like we should be able to make this compact. Let's get rid of the table underneath. We should make it compliant so I can put it on my body, for instance. I want to make it silent. And then the design part was kind of an insight that I got during my PhD where I was like, interesting. The table's only one part of the equation. I always thought about the hardware. We need lots of money. We gotta build this. You know, it's like every motor costs $20 and we need 900 of them and then lots of stuff on top. So the hardware is the hard part, right? But then I realized that actually the really hard part is thinking about the design tools. And so now that we're half an hour into my talk, let me talk about all of that in the remaining time. But So, number one, I want to mention all of this. These are a few of the people I've worked with. So this is kind of like up to my PhD, and then my research group, which was called the Thing Lab at Atlas Institute at CU Boulder. And at the bottom here, you see the wonderful PhD students I've worked with in my research group. And then, Albert, I'm sorry, but your photo comes up. I just realized. So there's lots of people I forgot in this slide. But so this is just a sampling of all the wonderful people I've worked with. Ryo Suzuki, who's now a professor at CU Boulder, who was my first PhD student, worked on a lot of this work. And so the very first thing we were like, okay, we realized we can move objects on top of the shape display. So we want to be more expressive than just pins going up and down. So Ryo was like, and we have been using all these building blocks, kind of like Lego, and trying to push them around to assemble objects, right? And that kind of worked well enough. But then Ryo was like, why don't we use the shape display as a super fast 3D printer? It could just like print Lego things for us. So he literally used a real 3D printer first, and built 3,000 of these cubes, and hand pressed magnets, spherical magnets into the side, so they would like snap together, and then uses the shape display mechanism not to touch directly, but to kind of rapidly assemble objects. And so the cool part now is, say for instance, you can assemble like furniture or an airplane or other things, and we're all kind of low resolution, but let's glance over that fact right now. And it's going to make it for you, and then you can also remove it, you can reassemble it, you can use computer vision to actually say like, this is how I changed it, and then you push it back in, and you keep assembling the next object. So you could send it over, say, to your colleague, and rather than having to like turn on an FDM printer and smelly and whatnot, they like get the nice Lego-like object out of the printer in like a few minutes rather than hours. So this was a collaboration with University of Tokyo, I should mention, Yasuka Kei's lab. And then we were like, so that's number one, but we really want to get away from the shape display, because we have like, they're bulky, they're annoying. So we're like, what if instead of having to haul around, like I was like shipping one of these tables to Milan once for a design exhibit, and it was like a ginormous undertaking, and it was so hard, and I lost sleep, and I was like, what if instead of having to ship these giant flight cases, we could just like have a bunch of robots. Like I open a suitcase and I drop out a bunch of robots, and they just come together and make a shape display, kind of like Big Hero 6 or something like that, right? So we're like, let's try that instead. So this is it's never as impressive as the story originally, but this would be the robots, right? We open our suitcase, we drop them on the table, and now we have a shape display that is like on demand. So each one of these robots not only is able to move around, kind of like your little, Lego-like robot, but also is able to change shape. So they have these reel actuators, which are very much the same thing that you have in every tape measure, right? Just with a little motor. And so that way we can explore different output design dimensions for each one of these robots. We could do like auxetic materials. We could try Hoberman mechanisms. We can have like simple 1D shape change. And then they come together on demand and tell us things, depressing facts about, I don't know, public health or elections or any other depressing thing that you want, climate change. Or they could, I think that's the more interesting thing, less depressing. They can interact with the world, right? Like here the idea is like they clean up the table for me. I never have to clean up myself again. There's like these kind of little robots. This one is my favorite example out of all of them. Because the idea is that if we have them in our world, so they can be shape displays, but they could also like augment existing objects. So here we brew a cup of tea and it's hot, it's too hot. So now we turn this teacup into a computational object. We give it dynamic affordances with these robots that make a fence around it. And I'm like, don't touch. And they're like, now touch. It's good. I'm like, wow, very good. Thank you. And then there's kind of the constant, I think that design tech students will enjoy once again, or architects, like this idea of like CAD, you know, because I think CAD is a very good example. For one, because I think that it kind of is always annoying to do it on a screen, even if you're good at it. But also it's like one of those things that I think really hasn't permeated society well enough yet. Like I really think CAD is something every human should do all the time. And the main reason is that we don't have the tools to do so. So there's a bunch of examples. Then we were like, okay, we have these robots, they're small, they're fun, but what about we have the same idea, but we make it like on a room scale, right? So we have shape-changing robots, let's make them room scale. And that's the image that I took. This is also Ruo again, standing in VR. And so we built these robots. We were like, what about a swarm of robots that is just able to keep rearranging things in a room? And so we bought these Roombas and then went to Target and got like laundry racks and started modifying because we wanted to make a swarm. There's like 9 of them, so they had to be cheap. And so the idea is this was the first application, and actually the only paper we published on it, even though we were thinking about it a lot. The idea here is to say you're in virtual reality, and anything that you see in virtual reality, like you see a chair right here in VR, you should be able to actually sit in it. You see a wall, you should be able to touch it. You see a table. There's this story back to Meta, like Mark Zuckerberg apparently was convinced to drop billions on Oculus and buy them and get into VR because he was like had a cup of coffee and was in VR and then put it down and then the cup like fell on the floor because there was no real table there, and he was like, oh, this is powerful, you know. So we were like, if he had a real table, I don't know, maybe he wouldn't have bought him. We never know. It's small things like that. But so here we have, so one of our research ideas here was to say these robots are all fairly small, fairly slow, and fairly not very powerful. So you can never sit on a robot like this. But luckily, we have Swedish flat pack furniture that is very flimsy and lightweight. So we can move around all these IKEA tables and chairs. So they're good enough for that, but they're still too slow. So I teleport in VR, and I want to like, you know, the chair's right over here. I want to sit down. And then, you know, when you're in VR, you teleport yourself, and now you're over there. And so the chairs should suddenly be here. And so the robot might not be fast enough, right? All this. So we were like, if we have a swarm of robots, I can't see shit. Like, I can't see things, right? So they can like trade off. Like if I know the trajectory that I'm gonna walk as I stand up from this chair to the chair over there, this robot might be too slow, but there's a robot over there with another chair on demand, and they're like doing a little switcheroo. And so we managed to maintain that illusion. And we were surprisingly good at it, actually, for this being a fairly low-tech project. And that's kind of this idea of like handing off tasks very quickly. So that's room shift. And I should also mention for all of these, I mean, we'll have a Q&A after, but there's also like little paper citations with all the people working on it, but then also more details for each one of these projects. So do feel free to follow up. We did a project that was published where we, not published, sorry, but that at least got us some money, where NASA sponsored a research project, a follow-up project on using this for astronaut training. So the idea is they were like boots on the moon. Does anybody remember that? Boots on the moon. Like we have a space force with boots on the moon. And so the idea is that they're called extravehicular activities, EVAs. And we got to train the astronauts for that. And that's very expensive. You got to put them in a tank or so on. But they're also using VR a ton for it. And so the idea is, can we have all these things? If I have a rock that I pick up on the moon, could a robot bring that rock? Any terrain features and so on. So we worked, this is Sweeby and David, they did this project. And they were looking a lot at like, also could we use the robots to trick you into thinking you're in a much larger, you're like on the moon in a very large space, while you're just in this small little contained room. There's this technique that is very common in virtual reality, commonly used, called redirected walking. So the idea is you think you're walking in a straight line, but you're actually walking in a curve because we're rendering, we're redirecting you. And as long as you do it subtle enough, you're not going to notice it. If it's not subtle enough anymore, you start to throw up. So you want to like be somewhere in between. And the robots can actually help with that, which is very nice because they can direct your attention as you like turn. So we did that. Like this was with a robot called Spot by Human Dynamics, which is like this walking robot. We had it. It was like left over from another research project, and we're like, this is cool. We want to work with Spot, and so we had Spot guide people around and redirect them in various ways, and never published it so far, but we're working on that. In any case, that's redirected walking with robots. There we are. Not on the moon, but nonetheless. So then we were also like, so these were all similar electromechanical assemblies. We have robots that are based on servos that move around in different configurations. We were like, we should really look into materials, different materials. And I think that's my personal conviction that with these standard electromechanical assemblies, we can only get so far. Like there is no way. There are just limitations to what you can do with a servo motor and a rigid linkage. And it's not going to replace your cell phone. But what I do think is going to replace your cell phone is new materials in material innovations. And so one very simple one was this one here, where we were like, we've been playing around with soft robotics for quite a long time. The idea here is this is a soft robotic actuator based on a constant force spring. So you can have a lot of volume, lot of expansion from a very compact tile. We call this project lift tiles because we were thinking about it. Think about these tiles here. We were like, each one of these tiles should be like an actuator like that. And because they're small and compact and super cheap, we could just like walk into a room and put these tiles everywhere, and then we have a programmable room, right? We just need to have a noisy compressor in another room and an air hose. Here they are, the tiles are all laid out, and now we can move them. If you're interested in how these constant force springs work, it's pretty fun. It's like the same as like your party horn, right? So imagine you blow into a party horn and it expands linearly. And the spring kind of retains it in a sense where the air volume will literally make a very nice linear expansion rather than a balloon when you inflate it, which expands in all directions. And so this was lift tiles. So we were like thinking about these soft robotics, but that still requires an air compressor, which we may not necessarily have at our disposal. So we were like, we really need to find a technology that doesn't require external pumps, right? This part is really nice, actually, but you don't see the pump, and there's a reason I don't have the sound on this video. So we kind of got lucky because at the same time that we were thinking about this, we discovered that Christoph Keplinger, who's a professor in mechanical engineering at CU Boulder, had been inventing these new actuators based on electrohydraulic principles. So they're called Hazel actuators, and the idea is that you have imagine a little plastic bag that is sealed, right? And inside the plastic bag you put vegetable oil or any other dielectric. There are some that work better than others. But you have a dielectric fluid inside, and then these black parts here are little electrodes you print or you paint on the outside. And so this is a very cheap, very inexpensive little actuator. And then when you apply 5 kilovolts to these electrodes, they start wanting to pull together. And so you can exploit that effect very nicely for making soft muscles. And these are what's really nice. They're compliant and they're silent. They're also pretty low power, high voltage but low power. So they'll definitely give you a good sap, but they're not they're not inherently dangerous. And you can turn them into really nice haptic actuators. So things that you wear on your body. This is Fernando, who was a PhD student. I co-advised on this project, and I saw on his LinkedIn he joined Cornell, so he might be in Ithaca right now. If you see Fernando, tell him I said hi. I tried to find, but what Fernando did, which was pretty amazing, is he built a whole fabrication pipeline. He did that in his kitchen, actually, because it was COVID at the time. So he put everything home. And I was always like, I hope they're really not dangerous, because if you sap yourself alone in your kitchen during lockdown. But anyways, so he built a fabrication pipeline where he built a CAD design tool. He actually made a plugin for Grasshopper. And with that plugin, you could simulate if you heat seal a certain shape and you fill that and then you paint an electrode on it, how is that actuator going to behave? Like, what shape is it going to have when you turn it on and when you turn it off? And based on that, so you kind of have this simulation tool, and then once you have that, it would give you the files, the fabrication files. So the G code for heat sealing, we had a very cheap little modified 3D printer, just using the hot end to heat seal plastic. And then it would give you instructions on how much oil to fill in, and then little instructions on how to paint the electrodes. We usually painted them by hand. And then cutting out the extra material, so you don't have arcing and other things. So you kind of have a bunch of heuristics, but then have a really good, easy fabrication pipeline. Because our idea was the power supplies for these things are expensive. And that's because they're high voltage electronics, but not unnecessarily. I mean, not necessarily expensive. Like in the future, they could be very cheap. We have high voltage electronics in our houses already. But what's really cool about it is that, for one, these are very cheap to make. You literally just need this $300 3D printer, or you could heat seal by hand. And then you need vegetable oil. You literally go over to a Costco and get that. And then you need to paint the electrodes, some flexible electrode. But none of it is. So it's really cool because designers could actually use that, and they could make their own Hazel actuators on their kitchen table, which we found out. And then it's this funny integrated design challenge that you have, because the shape of it is directly mated to how it behaves. So you really kind of have to think about it. And for those of you in our class, when Guy was talking about linkages and mechanisms today in his lecture, he was mentioning that there's a science to it, and we use an optimization, but historically speaking, there's also this art to it that is a lot about intuition as well, and about actually playing around with the shape and having an insight as you work with it, not just by using some automated tool, because very often you have to use the thing to think with the thing, and I think that's crucial. So that brings us a little bit more to designing for elastic spaces. And I know I'm going pretty late, so I'm gonna rush through this in the next 5 minutes. So we have a little bit of a Q&A time as well. But the very first thing, so if you do user interface prototyping, most people jump to Figma right away. Who here has been using Figma in the past for anything? I see a few hands up. Who has never heard of Figma before? So Figma is a tool for making user interfaces, right? It allows you to quickly sketch out, so to speak. This is not Figma. This is what I tell my students they should use before they use Figma. But so it lets you make a layout of, say, a phone app and then test it very quickly. Within a day, you can make iterations on it. With paper prototyping, it's a little bit more tedious, but I think more beautiful in that it's more interactive. So you're actually say you want to design a phone app and you're making it all on paper, and then you're talking through with your target audience. And you'll be what do you think now? And then you press a fake button and you swap that out and so on. The other one that I really like is Wizard of Oz user testing, which IBM pioneered in the 1980s when they were first working on speech interfaces. This is actually a figure from their original paper, where they were like, we don't have the tech to design speech interfaces, but we want to, and we want to find out whether we should spend the money on that. And so they were like designing these office interfaces where you sit in front of a computer and rather than a keyboard and mouse, you actually you speak into a microphone and you dictate a letter, for instance. And then the computer types out the letter for you and talks back to you. And so the way they did it was just like, having somebody sit in another room and have like a microphone and then or have them type out things and then use a speech computer. So it would really feel like an actual like computer that is very good at transcribing and so on. And let you focus on the user interaction rather than on the technology, which I think is crucial. Because we always think, if only the technology were a little better, then it would be great. But then we find out the technology is great, and I may not want to talk with my computer in a crowded office at all times. So Wizard of Oz user testing and paper prototyping are the two most important tools, I think, that hopefully will never go away. And so I was always thinking about like, okay, what do we do about these? Like, because the problem with this hardware stuff is, hardware's hard, right? I mean, I was lucky because I didn't have to design any PCBs when I did my first shape display. And then when we were like, let's do a more high-res shape display where we do need to design PCBs and where we do need to make very expensive decisions very quickly, we were like doing these video prototypes. So this is Sean, my colleague here. And we were testing what would a shape display with 1,500 pins look like as a stop motion animation. We just laser cut a lot of pins and put them in. And that took us, 2 days of making and then stop motion animation. But at least it gave us an idea, only it wasn't really that interactive. Once we had the shape display, suddenly it became a lot easier. One accidental discovery was we did this whole telepresence thing. Where it was like, you have your basket over here or your shape and it gets replicated. And we started using that a lot for like actually designing user interfaces to do Wizard of Oz user testing. Where we're like, we do an app and we say like a button should appear over here. And then we just move a box over there, where the basket is. And so suddenly a button comes up and then the person is like, I'm pressing the button, press down on it. And like, next thing appears. And so you can really like start to get very interactive like that actually. And so this for us was a perfect platform for Wizard of Oz user testing. And so I started working more and more and more on design tools. Like my colleague Philip Schössler in his master's wrote a plugin for 3ds Max. So you could like drag over any 3D shape directly, like simulate it and drag it over. We had very nice like rendering pipeline set up for content. And that became really nice for me. Like for instance, Luke, Verge, and Ken, 3 master students at the time, were like working on this. They essentially just used the shape display that was already there, and then the design tools for the shape display to like envision this like future living space. And for me, that was awesome. I was like, this is amazing. I barely had to do anything for this project, like answer a few questions and give a little bit of input, and suddenly have a paper out of it. This is like what it must feel like to be a professor. And so this idea, I was like, oh my God, design tools is where it's at. And so we kept doing more and more and more of that. Because I was like, back to Figma. Like we always think that the phone's the ultimate interface and everything looks kind of the same on my phone until somebody like designs something new, and then it goes actually, what I'm saying is when you open an app very often, there are standards that we follow, but there's also kind of a lack of imagination. And that's because the design tools we have constrain our imagination. I'm very convinced of that. And so whatever tool I have, that's what I think with. And if I don't have the right tool, all I'm going to make is apps, because apps are easy. Like I can open Figma and make you a nice app in a day, and I can show it to you tomorrow, and you can try it out and give me feedback. I can't do that with a shape display. We can't prototype right now. So why can't we? We should be able to. So design tools are crucial. These are like a bunch of projects that I barely worked on. Like I didn't even know about the second one, for instance, which is a musical instrument on a shape display. And that was just because a student who had access to the shape display was working on it with the tools, right? And so to me, this became really powerful, where I was like, this is more than building the hardware. So how can we do low fidelity prototyping? Albert knows the answer, sitting in the first row here. This was a project together with Malte Jung and Wendy Ju at Cornell Tech. It started there. There was this idea of could we combine Wizard of Oz prototyping and paper prototyping to make this design environment where things are really, really easy. We have this beautiful Ran, who's the third author here, was drawing all these amazing. Was that Ran or Adam? I actually don't know. Anyways, drawing this complex graph that looks very impressive. It was Adam. Okay, Adam was drawing it. Sorry, it's not Ran. And the idea here is, if we want to make a physical, interactive environment of the future, could we prototype that very, very quickly and then resort to virtual reality? I'm not 100% happy with VR, but I do use it, to kind of do a Wizard of Oz user study. And so I'm going to show you really quickly, and then we'll go back to what it looks like. So this is Mel. She was a master's student in our creative technology and design program at CO Boulder. And she was really good at cardboard prototyping. Here she's making a cardboard Rosie the robot for a future home environment. And then we were like, I, at that point, was thinking about moving to New York. So we were like, apartments are going to be tiny in New York. It's gonna be horrible. So we'll need future apartments, micro apartments, where things shift, and robotic, right? So we were like, let's prototype the environment first. Here we have a bed that can transform. We have a robot. We're going to have a desk. It's a small space, but we'll make do with technology. And so first, we're going to design that environment with found objects and crafted objects. And so this is kind of like our own discount version of Google Tilt Brush, kind of like a cheap sketching software that then we tether objects to the sketches that we made. So sketching rather poorly, but nonetheless. So we have an environment, we have objects, and once we go into virtual reality, here we are. Here you can see this is overlaid. I composited, but the user, in this case, my wonderful spouse, is not experiencing any of this, and she's a trained architect, so I gotta impress. And so this is what she's seeing, right? She's like, I wake up in the morning and then I do my gesture, and bed transform, make some space, and the bed moves away, right? But in the background, it's like me. I'm like, haha, I'm the wizard. I'm transforming the bed. She doesn't know. And then likewise, she's like, now that I have space, I'm ready for my coffee. So let's see, a little cheesy, but nonetheless. There we go. Is that working? Oh, there we go, yeah. And she's like, robot, bring me my morning coffee. And again, in comes Rosie the robot. And he's like, hello, here's your robot. And it's like, to live in the future. Nice. All right, it's 5:30, and we're at the end of design tools. And there's a million things I want to show you. We did things with children, co-designing robots on tabletops over a long time. We did things with designers. Rancho, my superstar PhD student who just joined KTH to finish her PhD, and I'm very pleased and honored to co-advise her, has been working a lot on body-worn shape displays and haptic interfaces, and the idea of how would designers actually, what would a Figma look like if it were for haptics? If we think about both the hardware and software, and how do designers actually approach these questions? And there's so many amazing things that I wish I could tell you, but I also have to answer some questions. So thank you very, very much. I'm just going to keep cycling through Ron's gorgeous research while we open it up to questions. But yeah, thank you. This was a really lovely paper, by the way. We were looking at, what are designers actually thinking about when they have an interface like that, and we tell them design some emotional touch. Like, what are the metaphors that they use? What are the different approaches? Like, what are they thinking about? Because we were like, if we want to design tools, we have to actually know what's going on inside your head for that. And this one, it's a beautiful pictorial. I highly recommend you read it. That would be a whole 1 hour talk in itself. And then likewise, the follow-up paper, or not really follow-up, but second paper that Ron was working on, which is Tactobots, an open source haptic design toolkit for body-worn haptics. Yeah. Go ahead.
Lovely presentation. Yeah, so I was definitely drawn into your sentiment about, because we often think of like tools as extensions of ourselves and like wanting to be more integrated with the tactile and like, the body in that regard. And also kind of your career in academia and your experience as an educator. I'm just curious to know, like going forward with tangible interfaces in general, how do you envision them like teaching us and like allowing us to extend ourselves beyond what we know? So,
yeah, teaching. That's a very good question. I was like, this is like, I should really not have any students of mine in here, because you're all just going to be like, you're talking about all these design tools, and then have we done any of that in the class actually? And I'm like, we should. They're not ready, but part of it is definitely, I think, I was glossing over a little bit over the project here, Wizard of Props, which I think has much more depth, also because it was like one of those forever projects that finally, when Albert joined and was like, we're gonna make it happen, that's when it actually happened. But so this idea, I think that one issue I have with teaching tangible interfaces and physical computing in general, from a teaching perspective, is that there's always a power dynamic in the room. And I've done it for a couple of years now, and I've always seen the same power dynamic, which is there's the people with the knowledge, and then there's the people with the ideas. And sometimes those are separate. So what I'm saying is, you very often have a team that you build up. We usually do all these projects in teams. And then you have your people put hats on. That's a standard dynamic. You have your designer and you have your technologist. And so you have like the person who knows how to code, they're the technologist. Or maybe they've done like some electronics in undergrad, and so they're the technologist. And then you have the designer who like comes from it, they're really good at like videos and rendering and drawing. And then very often there's a mismatch between them, because with all these projects, it's like you run out of time, you run out of money, and you gotta deliver something. And then it's the technologist who usually wins, because the designer's like, can we do this? And the technologist is like, no, I don't feel like it. And so they're like, no, it's not possible. Sorry. They literally hold the key, so to speak. And that's the dynamic that I observe. And then we usually talk about this design cycle, right? We have the diamond model, or we have like some form of iteration where we have many ideas, then we converge, then we like try different iterations with humans in the loop, and then we like have our final design. I've never really seen that happen. It's very often like there's a discussion phase where we do brainstorming. Then there's the first prototype, even the first cardboard prototype, and people very quickly hone in on that. And then they iterate very slightly, because we don't want to throw away ideas we had. We've already invested too much. And then the technology is like, I've already put in work. Why don't we throw that away? Just because we found out the idea is no good. So I think the tools are all about flipping that dynamic. I think that's what we have to work on. And I think that there's a ton of great work in co-design. For instance, like we were doing this project here, which was with a hard project actually. This was with 7 to 11-year-old kids, and we were working with this research team that Jason Yip is leading at University of Washington. So he was doing these co-design sessions with kids in person. The idea with co-design is you don't design for kids, you design with kids, and you fully engage. And that's exhausting, I can tell you that. But you really like take them serious. Where was I? And that's tough because we don't want to take, like, that's where you find yourself as a technologist, because we're like, I can add 2 and 2, and I know it's 4, but you think it's 5, you silly child. So we were like, and so during the pandemic, like 2020, all of that co-design switched online. It just had to happen on Zoom. They were like, we don't want to like stop it all together. Usually they're in a room full of stuff with Legos and bags and papers. And they were like, no, let's do it online. And that failed pretty much. Like it was no fun, right? Like imagine doing the same thing on Zoom. And so we were like, let's do co-design with robots and materials. We were like, first, let's do it just with materials. We shipped them like clay dough and lots of things. And we were like, you do things at home. And they would do things in the kitchen at home. And they'd be like, this is boring, and go make noodles, and they come back and so on. But we were like making these connected tabletop robots. We were like, you can play together over distance. Tell us what you want. And I constantly found myself in this thing where I was like, I know how to program them. I actually don't. It was Casey, who's the PhD student who was working. She was the one who was programming them, like the whole WebSocket communication between all the robots and so on. But there was constantly this thing where you're so tempted to like use your power dynamic of saying, I have the tools, I have the technology, you don't. And that's where we're going to have the discussion. And this was a big learning process. I mean, we did this for like 26 months, like session after session with the kids. 13 kids and 24 adults over 3 years, essentially. Sorry, 2 years. And it really like teaches you that you don't listen usually when you think, because everybody thinks they're smart. But so having the tools, because I think that's going to change very quickly. Like now you can ask ChatGPT to make working Arduino code for you. You can go on Figma and design a working app for a phone. Like things are like, there's already some dynamic shifting, but the problem is like the imagination's all very much like screen-based, agent-based. It's like voice interfaces and apps. And I don't want to make more apps. I think we have so many wonderful people making good apps already. I wouldn't be able to make a better one. So I want to focus on this. Like what's the Figma of this? Like how can we give this to anybody who's never seen code before but has a lot of design intuition that a CS person may not have. So, yeah. That was a very, very long-winded answer. I'm sorry.
Thank you very much for this very informative talk. In the beginning of your lecture, you mentioned that after graduation from MIT, you wanted to join the industry, but you didn't find it very appealing or very easy to navigate. I can see a lot of potential in some of your projects for real life circumstances, for example, usage in surgery rooms or hospitals. Do you work on making some of these proposals a reality or mass-produced? Is it possible to think about these things on that front as well as academia or not?
First of all, I should mention, for one, that's a personal issue of mine, and I think an issue in our profession also, because when you work in interaction design, you're kind of lucky. Like, say, my partner is an academic. She's an architectural historian. She's not gonna she might join Google or some other company, but less likely than me to join Google. Let's say that. So we always have this, like, we have all these options, right? You can go in academia, you can go in industry, you can start your own company and probably get money. You just like wave your MIT degree and say like, give me money. And then hopefully they do, right? And so there's also the situation where the grass is always greener on the other side, because you're in academia and you're like, oh, this is all committees and boring old professors. I hate it. I want to make money and have real world impact. And then you're in the real world and you're like, oh, the venture capitalists just asked me to make apps. I want to be back in academia where it can be creative exchange of ideas. And so that happened a little bit to me with the startup. And I should say my co-founders are still going strong with the company. So and I'm like, please do and make lots of money so I can finally, but nonetheless, I do think that a lot of these are actually real world applicable. Like this project here, I should mention, for instance, was for one sponsored by Sony. They gave us the little tabletop robots, which are currently only available in Japan. So you can like import them through eBay, but they like shipped us a whole bunch of them. And they were like, they liked the idea because they were using them for education in Japan and China, but they were like, oh, US market is nice, but also this idea of using them for telepresence was appealing to them. So I do think that there are some applications. I think the number one issue that I have, like I was just, like this year I was working, actually, I still am working on a startup, which is actually a little unrelated, but working on coffee technology and haptics. I somehow like halfway through my midlife crisis realized I want to make espresso at home, and that turned into a whole venture where I like teamed up with some coffee experts and we were like, we'll make hardware. And part of that was also like, I realized the moment you take money for it, it's like sometimes the joy gets sucked out of it a little bit. So I'm like, maybe a lot of this has to happen more on like open source kind of basis. Like that's where we're at right now, partly with the coffee machine. We were like, how can we open source some of this? Because otherwise, you do all these, like especially hardware startups, nobody wants to fund them because they're just very intense and usually not very profitable. So there's constantly this gentle push towards, could you do AI and an app? Like even by the most wonderful, insightful investor, they're like, yeah, but what about an app and AI? Think about that. We'd love to give you a few million for that. And you're like, oh, maybe I should turn my idea into an app with AI. But also, does the world need me to make an app with AI? Maybe, maybe not. The coffee machine has some AI in it. The investors like that idea. but no, I think for real world impact, one thing that I have to say, okay, a lot of conversations, I'm just gonna, and this is gonna turn into a rant now that we may have to take towards dinner or something, but one of it is like, a lot of investors or a lot of people, real world people see this tech and see these ideas and they're like, this is awesome. And then they're like, usually like, this would be great for two things usually. One is for children. For some reason, they're always like, this would be great for children. Because I see children playing with Legos and this like reminds me of that. And robots, STEM robots. And the other one is like for accessibility, which I think both of those are amazing, worthy causes. I should actually mention that, Sean Fulmer, for instance, whom I mentioned earlier, we've worked together on these shape displays for years, and then he became a professor at Stanford. He's in the mechanical engineering department at Stanford and building shape displays for accessibility. So for blind users to do computer-aided design, for instance, through touch, like amazing stuff. And I absolutely love it. But I'm also like, you tell me this should be for kids and for people who may have trouble using a laptop, but you are neither a child. I mean, you may have lost your child at heart, and you're currently on your laptop. Like, do you genuinely think you have found the best interface? Do you think that your phone, your laptop, is what the future of computing should look like? Because to me, that's frustrating. I don't think so. I use them every day. I don't have another choice, but that's not how I want to spend my life. That's not how I want my child to spend their life when they're an adult. I think we should really reimagine what we want our environment and our interactions with each other to be like, because they're entirely shaped by the medium we use to interact with each other. And so that's, to me, the kind of bigger question. And that's not a question that like a lot of people will give you money for, to like build robots that may replace a laptop, because it's just not feasible right now, but it might be. So yeah, I'll leave it at that. Hope that answers some of it. Any other? I should see if I have any other slides that I omitted.
Hey, Daniel. Thanks again for the lecture. You started talking about physical telepresence, and as we sort of went through your presentation, the idea of human presence sort of, maybe moved out of it, because we're talking about robots working for people. So
Yeah.
I guess especially with talking about working with children who are learning, what is the implication of presence and touch, like the psychological impact of moving to this sort of physical computation?
So if I understand your question correctly, you're saying like when we add touch to the equation, because right now we usually don't have a haptic interface when we use a computer. Like, what does it add psychologically? Is that?
No, sorry if I didn't make that very clear. I guess if we have less people and it's more just computational presence than physical telepresence. So is there an amplification where we're assisted by these sort of interfaces, but there's the heat of human-to-human contact, other psychological sort of things that transfer with that are not as present?
Yeah, that's a good question. I mean, I maybe going back to like my, I'm like very easy to dismiss people, and like this one, I'm always like, this is dystopian, it's horrible. But like, if I think about like adding robots to this, would that make it much better? I don't know, right? And I am worried about this idea, this implication that, we're not having this goal here, right? We're just having more and more robots and technology, and maybe that removes us from each other. I'm not entirely sure though, because I think we're already at a low point right now when it comes to human-to-human interaction. Like I genuinely find it hard to imagine it getting much worse. That might sound really pessimistic, but it's actually optimistic, because I think that, like, essentially what we have right now is slot machines in our phone, right? And everything we do, every interaction we have is dictated by that. Like, I mean, I feel that viscerally all the time. Like, say, for instance, yesterday when I was biking home from here, I have like a little folding bike, and then but my place was in South Hill, I think is the name of it, where Ithaca College is. That's where I stayed over the night. So I like biked down the hill. That was fun, really nice. Then I was like downtown, and then I had to bike up like another hill, and that was like really tough. And I was like, this is not fun. I don't like it. I wish there were a bus or an Uber or something, right? And I was like, if my bike right now had a button, were an electric bike, I could zoom up this hill, and that would be awesome. And so it's like the shortcut, we have the shortcut. If I could transform myself onto the couch in my place, even better, right? I could watch Netflix or something, or work on my presentation, which I should have. But so what I'm saying is, like, right now what we have is we have a constant distraction, and that distraction is letting us be in the same room. We could see each other, we have each other's gaze, but we're so drawn in by it because there's a message, and I'm like, oh my God, it might be about my daughter. Let me check. Oh, TikTok. Let's keep going on with that. And it's like literally, and I think that we have these like shortcuts that we use constantly because it's so easy. There's no friction, and the friction being removed makes our brain very, very lazy. Just like if I had an electric bike, I have nothing against electric bikes. I would love to have one. But then I would use it all the time. I clearly would like zoom up every hill, and my legs wouldn't have to work hard. I think it's the same with this, right? I feel bad, and I have the option to like go there right away because there's no friction. And I'm like, I'll just glance at it, and an hour later, it's like I'm gone. And so I think the whole interhuman communication is already at a point where if we were to be forced to engage more physically with media, I think it may be unsuccessful from a say venture capital point of view, because we want maximum engagement and minimum friction, and we've already optimized that very, very well. But from a human perspective, I think we really gotta add some friction, and that would let us engage more with each other. So maybe robots can do some of that. I'm not saying that's the solve-all solution, but it's worth exploring a little bit more, I think. Yeah. Sorry, I'm really bad at giving short answers, and I hope you forgive me for that.
Thank you, Daniel.
Thank you very much.